Get ready to ride the wave of innovation because wave energy converters are making some serious waves in the energy sector. Thanks to China's groundbreaking megawatt scale wave energy device. This isn't your run-of-the-mill gadget, it is a colossal game changer. What exactly is wave energy generation and how does it stack up against other renewables like wind and solar? We'll dive deep into the ocean of renewable energy to uncover its hidden potential. And don't forget to subscribe and like if you see any value in this video. Wave energy, my friend, is like the cool cousin in the hydropower family tree. Instead of relying on dams and gravity to capture water's potential energy as it falls, it's all about harnessing the power of relentless ocean waves, translating their motion into a nearly limitless source of energy. In simple terms, wave energy taps into the kinetic energy concealed within those rolling waves, making it somewhat of a cousin to wind energy. Technically, they're both in a wave caching game, but they're playing with waves in different states of matter. First off, unlike wind, oceanic waves are not intermittent. And secondly, water has way more mass than air. When you calculate the potential energy using mass and velocity, it is spelled potential with a capital P. There's an ocean of potential energy just waiting to be captured. In theory, the US coast alone could generate up to a staggering 2.64 trillion kilowatt hours of energy. To put that into perspective, that's roughly 64% of the total US utility scale electricity generation the year 2021. While winter might put a damper on your solar power plants, it's a whole different story for wave energy. When the days get shorter and the chill sets, wave energy just gets stronger. But of course, there's always a catch. Just like with solar, the real trick is efficiently and effectively converting all that wave energy into usable electricity. At the heart of the challenge is the development of a supercharged wave energy converter, or WEC, that can not only generate electricity but also survive in the unforgiving conditions of the ocean. The earliest record use of hydropower dates all the way back into 202 BC in China. Back then, they used trip hammers and vertical set water wheels to grind grain and crush ore. So we return to China for the latest and greatest hydropower innovation. Meet the colossal beast, the Nankan Power Bank. I'm not kidding when I say colossal. The Nankan weighs a whopping 6,000 metric tons and can generate a mind-blowing 24,000 kilowatt hours of electricity. It's equivalent to the daily electricity consumption of around 3,500 households. From serpentine point absorber buoys to oscillating water columns that harness the power of waves to move air or turbines, and even some super innovative and quirky designs, there is a vast array of different technologies all competing to be the one that can efficiently and commercially unlock the potential of wave energy. So why aren't we seeing any wave energy tech all over the place like we do with turbines or solar panels? The answer, my friends, lies in the fact that unlike solar or wind energy, we haven't quite nailed down the best-in-class tools, techniques, or materials when it comes to wave energy converters, or WECs. The field of wave energy simply hasn't been explored as extensively as other renewables. According to Robert Threshold in the National Renewable Energy Laboratory, while there is a vast area of different designs out there, it is possible that we haven't yet invented the ultimate WEC. In fact, back in 2014, some experts estimated that wave power was about 30 years behind wind and solar. However, since then, the research in this field has nearly doubled. So what's been holding us back in this aquatic adventure? Well, my friends, wave power faces some unique engineering challenges. WECs have to be tough enough to endure the relentless tossing and turning by wind and water day in and day out for decades. And remember, ocean never sleeps. There is no escaping those waves. But that's just on a regular day. These systems also need to brave rough seas, storms, and even hurricanes. The ocean itself isn't exactly welcoming to our technology. Salt water is corrosive and can destroy metals and electronics. While we use waterproof casings and sacrificial anodes to shield some structures, salt spray remains a formidable test for ruggedized electronics and metals alike. There's also biofouling. Organisms like barnacles and algae are more than happy to hitch a ride on anything we toss into the sea, causing all sorts of problems. Despite all these challenges, the clean energy from the seas is just too irresistible to pass up. With the field as young as it is, there is a sea of innovative, weird, and wonderful devices all competing to overcome these obstacles and become the industry standard. The promising up-and-comer of the wave energy scene, CalWave's X-Wave series of wave energy converter devices. Designed and patented back in 2012 by CalWave, this incredible device is all about converting the relative motion of passing waves into raw power. The X-Wave's rugged design allows it to capture wave energy coming from any direction and even reposition itself in a water column to maximize its energy capture potential. In 2016, CalWave won the second place prize of $500,000 in the Department of Energy in the wave energy contest. And then it was off to the Scripps Institute of Oceanography for a 6-month trial run. During this trial, the X-Wave faced off against the biggest storm to hit the arena in a decade, and it held its ground. Large storms can bring waves that are simply too powerful to convert into energy. These colossal waves may even pose a threat to the WECs. However, the X-Wave can autonomously detect oncoming storms and skillfully reposition itself to safely duck beneath the waves. Pacific Northwest National Laboratories conducted an environmental impact study on the X-Wave and gave it top marks. The risk of entanglements and collision was minimal, and any potential sound or electromagnetic fields emitted by the X-Waves were effectively damped by its hull. To top it all, the X-Wave only uses green marine approved lubricants and oils, ensuring that any unfortunate chemical spill would be harmless. And about Nancon, I couldn't find any environmental impact studies for Nancon, but considering it just began the trial operation in June, a study might be in works. It is important to note that lubricants, oils, and biofouling are some of the reasons why wave energy hasn't been widely utilized in the past. The real question is, can the X-Wave generate enough energy to make it worth deploying it in the first place? The smaller X1 devices can generate about 100 kilowatts, enough to power a larger apartment. But their largest device, the X-Wave X100, can produce a whopping 500 megawatts. The company behind X-Wave claims that their devices are built to last 20 years or more. According to CalWave, the X-Wave achieves a minimum capacity factor of 40% all on its own. However, this can skyrocket to over 80% if it is co-located and combined with the offshore wind. You see, wind and waves make quite a dynamic duo. Waves are at their strongest in the winter months, while wind surges in the summer. When it comes to comparing the cost and lifetime power production of these generators, we often use levelized cost of energy, or LCOE. Both power and offshore wind tend to have relatively high LCOEs for similar reasons. But here's the kicker: co-locating these green energy devices can significantly lower the numbers. They can share electrical export infrastructure, save on real estate costs, and make maintenance easier, more affordable, since they're right in there together. So even though co-locating isn't a unique strategy to the X-Waves, but it is fantastic to know that this device is being engineered to seamlessly work with both wind and Lacoste. Understanding the precise environmental effects of WECs can be a real challenge. Why, you ask? Well, because the field is relatively young and there are a multitude of variables at play. I mean, we're talking about tons of different designs, each interacting with waves in their own unique ways, in a diverse marine ecosystem scattered across the globe. It is a lot to calculate, and the impact can vary significantly from one design to another. Take for instance the free-floating WECs that often use electrical cables to transport collected power back to shore. Marine life, including inquisitive sharks, can sometimes be drawn to this system. In fact, some oceanic fiber optics cables have been known to receive not so gentle test bites from these curious sharks. The exact reason behind this behavior is still somewhat of a mystery, and it's an area that we're actively working to understand better and address. Now, consider the loud air pump on an oscillating water column of a WEC. This noisy contraption might startle resting seals and sea turtles. So how do we take all these complicated interactions into account? I mean, that is an issue to be addressed, but wait, it gets even more complex. These WECs are designed to last for over 20 years. That's quite a long time. Studying and doing research on such long-lived devices, especially in this harsh and unpredictable ocean environment, presents its own set of challenges. Yes, despite these challenges, it is reassuring to know that companies like CalWave are actively conducting studies to assess how marine life will be affected, and these studies even consider the effects of scaling up these technologies. Speaking of scaling up, while it might sound straightforward, just build more, right? It is not as simple as it seems. The engineering and financial challenges have been historically limited the scalability of WECs. Of course, cost is a significant factor. WECs come with high initial cost, and both installation and maintenance can be quite tricky and expensive. This is because most WCs operate in or under choppy waters, which adds to the complexity. Finding suitable underwater real estate and safely anchoring these devices can sometimes cost 2 to 3 times more than a WC device itself. And both installation and maintenance often requires waiting for the oceanic conditions to be just right, which further drives up the costs. Even though it can feel like the ocean is a challenging and expensive place to operate, these challenges are worth tackling, because the potential of wave energy is just simply too incredible to ignore. According to Reza Alam from the University of California at Berkeley, every square meter of solar panel receives 0.2 to 0.3 kilowatts of solar energy. For wind towers, it's 2 to 3 kilowatts per square meter, and every meter of California coast receives 30 kilowatts of energy. This really puts the potential of wave energy into perspective, doesn't it? And the good news is there is every reason to be optimistic. A 2019 study from NREL suggests that if all goes well, the levelized cost of energy for wave energy converters could be as low as 30 cents by 2033, which translates to around $300 per megawatt hour. Now keep in mind that LCOE varies significantly from one site to another. For comparison, a study from the Energy Information Administration found that the average LCOE for solar farms in 2021 was over $33 per megawatt hour, and onshore wind came in at about $38 per megawatt hour. It is expected for wave energy to reach those price levels until 2050. Conservative estimate hovers around $130 per megawatt hour, but in the most optimistic scenario, we're talking about $70 per megawatt hour with a margin of just $30. Now, considering that solar energy is currently one of the cheapest ways to generate electricity, it is safe to say that it won't be losing the crown anytime soon. In this optimistic scenario, wave energy can certainly get into the ballpark. Wave energy is still a relatively new field, and its unique and expensive engineering challenges mean that it is not as mature as wind and solar. But the incredible variety of ways that we can harness the power of waves for electricity generation has made wave energy an exciting and promising field. And when you think about near limitless clean energy that our seas can provide, it is just simply too good to pass up. As the Nancan and X-Wave devices have shown us, once the industry finds its sea legs, wave power may well become one of the most potent tools in our renewable energy arsenal, as long as the cost can come down. So what do you think? Let me know in the comments. Thanks for watching, and see you in the next one.